Greetings of the day to everyone. The content we have learned, we have completed our internship at Emertxe, which focuses on embedded system and IoT based projects. We have learned about C and CPP. We also learn about embedded system and IoT application. We learned about home automation projects, which gives us information to control and monitor home devices using IoT. Now further, we learn about the learning outcomes. In learning outcomes, first is basics of C, learning how the C programming language works. Second, basics of CPP. In basics of CPP, learning CPP and how it is different from C. Embedded system and IoT. In this, how small electronic system connect with the internet. And the fourth, home automation projects. In this, will build a project to control a home device automatically. Basics of C. In basics of C, data types. As data types used to define the type of data stored in variables. In this, integral and floating point. Integral, int and character, which is basically whole number characters, and float and double, floating point, float and double, which is decimal numbers. Qualifiers. Qualifiers modify the behavior of variables. In this, constant and volatile. As the name suggests, constant, the value cannot be changed, and volatile, the value can change anytime, like hardware related values. Conditional constructs. In this, or it is basically used to make decision or repeat actions. In this, single iterations and multi iteration. In single iterations, if and its family switch used for checking conditions. In multi iteration, for, while, do while used for loops. Operators and their precedence, basically symbols used to perform operations like logical, assignment, bitwise, ternary operators. Other important concepts like arrays. Arrays is used to store multiple values of same time. Example, marks of 5 students. Pointers. Pointers store memory address of variables. String. String character arrays used to store and manipulate text. Example names. Storage classes. Storage classes like control scope and lifetime of variables like auto, static define variables, scope and lifetime. Header file. Header file contain function declaration and macros to organize the code. Hashtag like hashtag include. Basics of CPP. In this, we'll learn about C and CPP. C, how C is different from CPP. C uses POP, that is procedure oriented program, which focuses on function only, and it is step by step instructions. Whereas CPP uses OOPS, concept of OOPS, where object oriented programming focuses on object and classes, real world modeling. Concept of OOPS. In this, we'll learn about building blocks of CPP like class, objects of class, access modifier, constructors, and destructors. Class, a blueprint or template that defines properties and behavior. Object is a real time instance of class, like a real house built from the plan. Access modifiers control who can access data like public, private, or protected data. Constructors special function that automatically run when an object is created. And last, destructors, special function that run when object is deleted to free the memory. It is basically used for free the memory. Pillars of OOPS. In this, we'll learn encapsulation, abstraction, inheritance, and polymorphism. In, encapsulation is basically binding a data function together, like a capsule. Abstraction in this will show only important details and hide unnecessary ones. Inheritance. As we all know, inheritance is reusing things, like reusing code by passing traits from one class to another. And polymorphism. One function behaving differently depending on the situation. Virtual function. In virtual function, it contains like static linkage, dynamic linkage. Means virtual function is basically which allows a function in base class to be overridden in derived class. So static linkage decides function call at compile time, and dynamic linkage decides at runtime, achieving using virtual function. And runtime polymorphism, when correct function is chosen while the program is running. CPP features: namespace, an abstract that contains set of names. STL, standard template library, which is ready-made classes and function. Friend function. Friend function, it is basically allow one class to access private data of another class. And abstract class. The abstract class is class that cannot be directly used to create objects, only for inheritance. Now, further templates. Templates helps to write generic program types like function template and class template. Function template used for function that work with multiple data types, and class template used for class that work with multiple data types. Exception handling. Exception handling is a problem that arises during execution of program works on, and it basically works on three keywords like try, catch, and through. It works using three keywords: try, block of the code that might cause an error. Second, catch handles the error, and through send error message when something goes wrong.
Introduce the concept of Internet of Things, which is the network of physical devices connected to the Internet. First of all, what is IoT? It is a network of unique objects connected to the Internet. These are generally devices, not people. For example, a smart refrigerator or a smart light bulb. Then we see how it works. It works as a bidirectional communication. The device can talk to each other and to the internet, and the internet can talk to the back device. Second, data flow. This creates large complex data flow that allow for new type of insight. Then we see smart home. The key application of IoT is smart home. This involves using connected to the device to control and automotive things in our house like lights, security and climate control. Next we see embedded system. What is embedded system? The combination of hardware and software which is intended to do a smart specific task. For example, a washing machine, TV, smartwatches, Wi-Fi, automotive, etc. Then we see categories of embedded system. Embedded systems are categorized based on their function and behavior. First, stand-alone. These systems work on their own, following pre-programmed instruction and making decisions without human intervention. For example, a self-driving car. Second, real time. This system must be their task within a given deadline. If the deadline is missed, it can have serious consequences. Then, type of real time system: hard real time, soft real time, and firm real time. Then, network. These systems are designed to get connected to other systems or networks. For example, the network router. Next, mobile. These are embedded systems that are movable and are typically designed for devices like smartphone. Then we see Component of embedded system. Embedded system is built from several crucial components. First, processor. In processor include microcontrollers, microprocessor, SoC. These are the brains of system, responsible for processing the code and running the specific task. Then, memory. This store the program and the data it currently working with. Types: RAM for temporary data and ROM for permanent program code. Then we see sensors. These are the system's eyes and ears, which read information from physical world like temperature or light. Types of sensor: analog and digital. Then we see actuator. These are system muscles. They take a electrical energy signal from the processor and convert it into a mechanical energy. Then human interface. These allow people to interact with system. For example, switches and screens. Switches are input and screens are outputs. Then some basic programs are there. First, write a program to toggle LED. Second, write a program to print hello on CLCD on first line. Third, write a program to read value of from temperature sensor and display it on a CLCD. Fourth, write a program to test analog write function. Fifth, write a program to control brightness of LED with LDR. Sixth, write a program to control inlet valve and outlet valve. Including all these programs, we conclude our project.
Home automation projects. This project focuses on designing a smart home automation system that enables user to monitor and control home appliances and environmental conditions using sensors and graphical interface. This system automates functions such as lighting, cooling, heating, and water level management, providing emergency efficiency, convenience, and safety. So we use these softwares. First is Arduino board for writing codes of project. Second is Pixim Lab to simulate use to execute the code. So these softwares we used. First is Arduino board for writing codes of the project. Second is Pixim Lab simulator used to execute the code. Third is Blynk IoT. It can control hardware remotely. It can display sensor data. It can store data and visualize it. First is garden light control. The LDR sensor is simulated to sense light sensitivity. Depending on the visual sensor value, the LED brightness changes automatically. This simulates how garden lights would automatically turn on in the darkness and turn off in the daylight. This helps demonstrate energy efficient lighting automation in the virtual setup. Second is temperature control system. The LM35 temperature sensor is simulated to measure temperature. The measured value is displayed on character LCD. It helps to visualize how temperature monitoring works in the smart home automation environment. The data is also sent to the virtual IoT dashboard to real-time monitoring. Third one is cooler control system. The cooler control system is based on logic signal from the user interface. When the weight is logic high, the cooler turns on, and if the logic is low, then it will turn off. This shows how user can remotely control cooling system through software. So fourth one is the heater control system. Similar to the cooler, the heater operation controlled via simulated logic signal. If the logic is high, then heater is on. If the logic is low, then heater will be off. It demonstrates how temperature depends on heating control works in a home automation system. Fifth one is threshold temperature control. A temperature threshold of 35 degrees Celsius is set in the simulation. When the temperature exceeds this value, the heater automatically turns off and sends a notification. This showcases safety and automation features through software logic. Sixth is volume of water display. The water tank is simulated using virtual graphical interface. The water level changes dynamically according to the sensor input value. The corresponding data is displayed on the CLCD. This demonstrates how real-time water level monitoring can be implemented. Seventh one is Intel value control. The Intel value is operated using button wait in GUI. In simulation, logic is high, and if the logic is high, then opens the valve. If the logic is low, then close the valve. Commands are sent via virtual serial communication. Eighth one is outlet valve control. The outlet valve operates in the same way as the Intel valve. The virtual interface allows on or off control for overflow. This helps demonstrate complete management in a simulated environment. Ninth is automatic water level control. The simulation automatically monitors tank volume. If the water level drops below the 2000 liters, the Intel valve is automatically turned on and sends notification. Once the level reaches required limit is it turn off automatically. It demonstrates closed loop automation logic. Lastly, this is the output of home automation project.
Go to the Arduino IDE. Here we write our code for home automation Blynk control. This is our code for home automation. Now go to the Pixim lab. We, are, we all save this code. Go to the Pixim lab. We choose Arduino Uno. Go to the files, configure. Here we configure serial port to port COM3. Save it. Now go to the tools. Choose serial remote tank. It is connected to COM3. Sorry, COM2. This is connected. Now go to the files. Now go to the files, load X file. We save file on desktop, so choose desktop. Our file, build Arduino home automation. File is selected. Now go to the modules, square parts. Here we already take square parts. This is CLCD, this is LDR sensor, this is a LCD, this is a temperature system, and this is Ethernet shield. Our project is on. Now we check, go to the properties. Here we connected CLCD to its appropriate pins. Similarly, we connect LDR sensor to its appropriate pins on Arduino. Okay. Then we select Ethernet shield. We take Ethernet shield module ATHW5500. We connect it to its appropriate pins. This is temperature system. We also connect this temperature system to its appropriate pins. This LDR sensor shows the intensity of LCD. This light, it shows now light is dim, LCD is full glowing. Now we control this to by phone. Go to the Blynk IoT app on mobile phone. Choose home automation. This is a switch for heater. This is switch for cooler, and this shows the temperature of this temperature of this particular system. This is inlet valve and this is outlet valve for cereal tank, and this shows the volume of the water. Now we on the heater. LCD shows the heater is on and temperature goes increasing. Temperature is increasing. Now we on the cooler. Cooler is on. Temperature goes decreasing and cooler is on. Now we off the cooler. It shows cooler is off. Now we on the off the outlet valve. Tank is empty. The water level goes decreasing. Now we on the inlet valve. It shows inlet flow on. It shows inlet flow on. Now we off the inlet flow. So it shows inlet flow off. And it shows the volume of water and it shows the temperature of system. Now we can parallelly on both switches like heater, cooler, inlet valve, outlet valve. This is our home automation. Simultaneously, we can adjust the intensity of LCD like this. Okay.